Ever stood before an ancient wonder like the massive trilithons at Baalbek and just thought, how? How on earth did they move stones weighing over 1,000 tons? We're talking about blocks heavier than 3 Boeing 747s, lifted and positioned with breathtaking precision. The common story often whispers of lost technologies or even extraterrestrial help. But what if the answer is simpler, yet far more ingenious? What if it's all about physics, friction, and a level of human grit we can barely comprehend today? Today, we're going to pull back the curtain on this ancient mystery. We're not just talking theories. We're diving into the practical science that made the impossible possible. Forget everything you think you know about primitive tools. We're about to show you how a few simple principles, masterfully applied, were enough to shape the world. Let's start by challenging a common misconception: that ancient tools were primitive and therefore inferior. When we think of levers, ropes, and rollers, we might picture something crude. But in the hands of a master builder, these were instruments of immense power. The key wasn't the complexity of the tool, but the depth of understanding behind its use. These builders were masters of mechanical advantage. A lever, for instance, is a force multiplier. With a long enough arm and a stable fulcrum, a small group of people can generate enough force to lift a corner of a multi-ton block. It's not about brute strength alone, but about applying that strength intelligently. Imagine a team working in perfect sync, using a series of long, hardened wood levers. With each coordinated push, the stone lifts, just a fraction of an inch. It's slow, painstaking work, but it's effective. This isn't just a guess. It's a principle of physics that works as well today as it did thousands of years ago. The real genius lies not in a single big lift, but in 1,000 small, controlled movements. Now, lifting is only half the battle. How do you move a 1,000-ton block across the ground? The biggest enemy here is friction. It's the force that resists motion, the invisible glue holding that massive stone to the earth. Conquering friction was the true secret weapon of ancient engineers. You've probably seen depictions of stones being moved on wooden rollers. And that's certainly part of the story. Rollers dramatically reduce the contact area and change sliding friction into much weaker rolling friction. But the ancients had even more tricks up their sleeves. One of the most effective techniques was creating a slipway. This could be a prepared path of packed earth, clay, or even wooden tracks. The purpose? To create a smooth, consistent surface, but here's where it gets really clever. They would then lubricate this path. What with? Water is a simple and effective choice. By pouring water onto a clay or dirt path, you create a slippery slurry, a thin layer of mud that acts like a lubricant, drastically reducing the coefficient of friction. Think of it like hydroplaning, but on a massive, slow-motion scale. The stone isn't just being dragged. It's partially floating on this layer of muck. Experiments have shown that this technique can reduce the force needed to pull a heavy object by over 60%. Suddenly, the number of people required to pull the stone drops from thousands to a more manageable number of hundreds. They also might have used animal fat or olive oil on wooden tracks for a similar effect, creating an ancient version of a greased skid. These weren't happy accidents. They were calculated engineering solutions. The builders understood the properties of different materials and how they interacted. They knew exactly how much water was needed, the right consistency of the mud, and the optimal angle of the path. It was a science refined over generations of trial and error. Every detail mattered, from the type of wood used for the rollers to the weave of the ropes. Let's piece it all together and visualize the process. A 1,000-ton trilithon has just been quarried from the bedrock. The first step is to lift it slightly, maybe using a combination of levers and wedges hammered into place. Once it's raised just enough, workers can slide a massive wooden sledge or a series of rollers underneath. Now, the path ahead has been meticulously prepared. It's a gentle downhill slope, a perfectly graded road of packed earth. Teams of workers are ready with buckets of water, keeping the path slick and muddy. At the front, hundreds of men and teams of oxen are attached to the sledge with thick, incredibly strong ropes, likely woven from papyrus or other natural fibers. A foreman, perhaps standing atop the stone itself, calls out a rhythm. It's not a chaotic pull. It's a synchronized heave, and the stone inches forward, heave, another few inches. It's a colossal, slow-moving beast, crawling across the landscape. The sound would be incredible, the groaning of the ropes, the squelch of the mud. the chanting of the workers, all echoing through the valley. This process could take weeks, even months, just to cover a single mile. But with patience and relentless effort, the monolith arrives at the construction site. Once at the site, the challenge changes. Now they have to lift it into its final position, often high off the ground. How do you do that without cranes? The most likely method involves another brilliant yet simple concept: the ramp. Ancient builders were masters of earthworks. They would construct enormous earthen or rubble ramps, sloping up to the height needed. The same techniques of rollers, sledges, and lubrication would be used to pull the stone up the ramp. As the building got higher, the ramp got longer and higher. It was a monumental undertaking in itself. Building the ramp was often as much work as building the structure. And once the stone was at the top, they faced the final delicate task of positioning it. Using levers for fine adjustments, they could pivot and nudge the stone, millimeter by millimeter, until it settled perfectly into place. Then, the ramp would be dismantled, its material perhaps used elsewhere in the construction, leaving behind a perfectly placed monolith that would baffle future generations. It's easy for us, in our age of hydraulic cranes and laser-guided machinery, to dismiss these methods as primitive, but that's a profound misunderstanding. This wasn't primitive. It was precise. It required an encyclopedic knowledge of materials, a deep, intuitive grasp of physics, and most importantly, an incredible level of social organization and project management. You needed to feed and house thousands of workers for years. You needed to source and prepare tons of timber for levers and rollers. You needed to manufacture miles of rope. You needed surveyors, engineers, and foremen who could execute a plan on a scale that is almost unimaginable today. The construction of these wonders wasn't just a feat of engineering. It was a testament to human collaboration and perseverance. The true lost technology isn't some mythical power source. It's the sheer, unyielding power of collective human will, guided by brilliant, practical minds. So the next time you look at the pyramids, Stonehenge, or the temples of Baalbek, don't see a mystery that defies explanation. See a monument to human ingenuity. See the sweat of thousands of workers, the genius of ancient engineers who mastered the laws of physics, and the incredible power of a society working together towards a single, monumental goal. They didn't have alien technology or magical powers. They had wood, water, rope, and stone. And most importantly, they had the knowledge of how to use them. They understood leverage, they understood friction, and they understood that with enough time and effort, nothing was truly impossible. The greatest wonder isn't the stones themselves, but the human spirit that put them there. Thank you so much for joining us on this journey back in time. If you enjoyed unraveling this ancient puzzle, don't forget to hit that like button and subscribe for more deep dives into the world's greatest engineering marvels. Let us know in the comments which ancient structure you'd like us to investigate next. Until then, stay curious.